Example 3.1. A. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1 into 10 raised to minus 7 meter square carrying a current of 1.5 ampere. Assume that each copper atom contributes roughly one conduction electron. The density of copper is 9 into 10 raised to 3 kilogram per meter cube and its atomic mass is 63.5 U. B. Compare the drift speed obtained above with thermal speeds of copper atoms at ordinary temperature and 2. Speed of propagation of electric field along the conductor which causes the drift motion. Now see, here the information given to you, that is about area of the cross section 1 into 10 raised to minus 7 meter square. Conductor is carrying the current I, that is equal to 1.5 ampere. Density of the copper that is given to you 9 into 10 raised to 3 kilogram per meter cube and its atomic weight that is 63.5 gram per mole. Now we have the equation for drift velocity, that is J equal to NEVD, but J that is equal to I upon A. Now we want to find the drift velocity, so make VD as a subject of equation. So VD that is I upon NEA. I that is given to you, A that is given to you, E is always given. But here the number density of the electrons that is not given to you. So that we have to calculate. See, the atomic weight that is 63.5 gram per mole. So we can say per mole the number of electrons that is 6.02 into 10 raised to 23 because it is given to you in the question. Per atom, one electron is contributed. So the mass equal to its atomic weight 63.5 into 10 raised to minus 3 kilogram. The number of electrons that is 6.02 into 10 raised to 23. Therefore, in 9 into 10 raised to 3 kilogram, how many electrons are there? Now, this particular mass 9 into 10 raised to 3 kilogram, that is the mass per unit volume. And in this mass, when you calculate the number of electrons, impliedly it is the number of electrons per unit volume. Now calculate this one. You will get the number density of electrons, or we can say number of electrons per unit volume. Clear up to this one first. Now substitute the value of INEA in this equation of VD. So I that is 1.5, E that is 1.6 into 10 raised to minus 19 and area that is 10 raised to minus 7, and whatever the value of N is calculated, substitute it here and then solve. You will get VD. Okay. Now the velocity associated with thermal motion. So in standard 11th, we studied this thing. The kinetic energy of atom half mv square, that is 3 by 2 kbt, where kb that is Boltzmann constant. So V square, that is 3 kBt by m. So V, that is under root 3 kBt by m. 3 kb, that is 1.38 into 10 raised to minus 23 into temperature, that is 300, and mass of the atom. So of 1 mole, the mass is 63.5 into 10 raised to minus 3. Divide it by total number of atoms in 1 mole. So that is 6.02 into 10 raised to 23. And when you solve this one, you will get the answer 2 into 10 raised to 2 meter per second. So this is the velocity associated with thermal motion. Now we want to compare the drift velocity with thermal velocity. So take the ratio Vd to V. Vd we calculated here, and V, that is 2 into 10 raised to 2 meter per second. You will get the comparison. Then speed of propagation of electric field, that is the speed of light, that is 3 into 10 raised to 8 meter per second. So now to compare drift velocity of electron with the speed of propagation of electric field, take the ratio Vd to C, you will get the answer. Clear to all of you?